hi people at home. We've done the first example. We're on the second example. We're just figuring out the perimeter of this rectangle, and we remember that perimeter is adding. Okay? We were just organizing our like terms when I remember to start recording. So if you're ever sitting at home, that's what you'll hear me saying if you click on the video, okay? So it records everything I'm saying as well as the writing on it. And then I also post just the lessons filled in, okay? So if you start the video and you're like, I have the hang of this, and you just want to look at the lessons filled in to see a harder example and copy it out, you can do that without the sound, okay? All right, so we've got 20 x's and plus 12. Make sure you have the plus in between them, okay? How many people got 20 x's plus 12 for their perimeter? I saw lots. Very good. Awesome. Okay. Area is multiply. Some people did this one first, okay, because it's stuck in their head. And we're going to pick our length to be our one term, because we learned how to multiply one term by more than one term. So our width is going to be our more than one term, okay? And then we're going to do the distributive property to expand our brackets. And we remember that if we multiply 3x by 7x, we get 21x squared. And if we multiply 3x by 6, we get 18x. And that x beside the 18 is the one common mistake that a lot of people in grade 9 make, okay? They forget that x there. Because it's here, right? It's here, it's not here. So you forget it when you've done the multiplying. Okay, so make sure 3x times 6 is 18x. Now I want to point out something, because this has happened before. You forget that you want to have your 3x first. So you end up writing this out. So my question for you guys is, can the distributive property work like this as well? Yeah, because I'm still multiplying 3x by each of the things. So it can work backwards as well. Okay, so if you forget, just remember it's the one term thing that meets the people in the brackets. Okay, the more than one. So I've got 3x times 7x still gives me 21x squared, and 3x times positive 6 still gives me positive 18x. So if I forgot, I'm still okay as long as I remember to draw my arrows and multiply. Okay? All right, that's awesome. Okay, turn the page. And we have an EQAO question here. It's kind of blurry because I just snipped the picture right off the EQAO website, but this says 4x on this side, and this is 3x minus 2, and then they're just telling you that the measures are centimeters. So I'm going to let you guys all try. Which of the following simplified expression represents the area of that rectangle? So see if you could have gotten the right answer on this EQAO question. Which of those expressions is the area? So ask yourself, do I have enough information without looking at the answers to get the answer myself? If that's true, then just try it like the answers aren't there, and then look at the answers. So this is the important word, area. Area. Okay, so as I was walking around, I saw lots of people starting off their area question with area equals length times width. Perfect. It's a good reminder. A good reminder that we're multiplying. So I would want to put my one term in front and my two term 1 second. Distribute. And then be really careful when I'm distributing. 4x times 3x is 12x squared. 4x times negative 2 is negative 8x. So then I'm going to look through all these and see where mine is. It's at the bottom. And these are just units, okay? So don't let them bother you. Those are just units. I'm sure one of these answers would be the perimeter. If I've added up all the sides, I would get 14x minus 4. So they made that for you on purpose in case you added, okay? So they're sneaky. That would be if you found the perimeter instead. This one is if you just shook hands with the first person in the group and forgot the second person, you would have got the minus 2, which is another common mistake, okay? And this one is if you just added the two sides together instead of multiplying them, okay? So they know all the common errors, and those are the other 3 answers. That's what makes EQAO tricky, right? Because it's not just one answer that's close and the other ones are all way out there. They're all common errors that people make. Okay, how many people would have got that one right? We're just learning, so that's awesome. Good. Excellent. Okay, so now we're on to a compound shape. And in grade 9, applied, our compound shapes are going to be made out of rectangles, which makes it easier for us, okay? So we already know how to handle rectangles. We just have to, again, know the difference between perimeter and area. And in a compound shape, we have our decision on what to do first. Hands up if you want to do the perimeter first. And if you want to do the area first. You want to do perimeter? Okay, so perimeter, it doesn't matter, but we're going to do this one together. So the next one that you do on your own. But remember perimeter here, we don't include an inside side. So that's not part of our perimeter. Okay? So that's a really common mistake people make. Perimeter is just the outer edges, even if it's a weird shape. Okay, just the outer edges only. So just remember that, and then whether you're a counter rounder or you're line them up, you need to know every single side. Okay? And they don't give them all to you. Some of them you have to use thinking in order to get those missing sides. So I'm going to start going around in a different color, and I'm going to say, I know that side. I know that side. Oh, I don't know that side. So how am I going to figure that side out? Let's think about that. So put a little question mark there. I know this side. I know this side. What does it say? 4x plus 7. Thank you. 4x plus 7. I know this side. And then this whole big side here, I don't know either. So there's 2 sides that I need to fill in before I can figure the perimeter out. Does that make sense? I can't just add the stuff they give to me. I need to know every single side to add them up. All right. So let's look at this big top side here. See this big top side? If I just look from here to here, what's the distance from here to here in terms of x and a number? Do we know it? Yes. So this transfers right up there. So this is 2x plus 3. Does that make sense to everybody? And how about this bit here, just from here to here? 2x. So if I combine these together, so I have 2x and another 2x makes this top part 4x plus 3. Does that make sense? I now know the whole top is 4x because I have 2x here and another 2x here, which gives me the 4x plus 3. So now I've got one of my question marks. How about this one? So I'm running out of colors here. I know this whole big side is 4x plus 7. So this whole big side here is 4x plus 7. Does that make sense? So the whole thing is 4x plus 7. This much is 3x. So that much is 3x because it just transfers over. So what would have to be where the question mark is? What do I add to 3x to get 4x plus 7? It's kind of like yesterday's missing side question. So I need 4x. Yes, this whole big thing is 4x plus 7. What would I have to add to 3x to get 4x? That would have to be on that side. No? Okay, I've got 3 x's here. I need 4 x's to make the whole side, so that means I have to have an x here, because x plus 3x gives me the 4 x's I need. Yes? Kayla? Plus 4, plus 7, good. Because I don't have any plus ones here, and I need all 7 here. Okay? So now I know all of the sides, every single side. So now whether I'm a count arounder or a liner upper, I can add all the sides together. Remember I said checking them off is a good idea? Because we have so many sides, so I've got my 3x written down. Then this big side across the top is 4x plus 3. Then the big side down here, 4x plus 7. Little side at the bottom, 2x. Side we figured out, x plus 7. And last side there, 2x plus 3. Going over onto the area. Okay. So a couple things we learned there. We don't just find the perimeter of one rectangle and the perimeter of the other and add them together. We want all of the outer sides only added together. Okay, so that's a common misunderstanding there, is I want the perimeter of this one and the perimeter of that one and add them together. That's not how perimeter works. It's just the outer edges only added up together. Okay? All right, so now we're going to look at like terms. And we're going to line them up. So 3x, check, plus 4x, check, plus another 4x, check, plus 2x, check, plus x, plus 2x. And then we've got a 3, a 7, a 7, and a 3. A lot of terms there. Or 16x. I got 3 and 4 is 7, and 4 is 11, 13, 14, 15, 16. 16 x's. Yes? And then how many ones do we have? 20. 16x plus 20. 16x plus 20. If you're confused with that one, put a little question mark on your sheet, and when you have your time with your tutor, you can go over it again. Okay? 16x plus 20. And there's some in the practice that we'll take up later too. All right, so for area, I'm going to erase all this. Because area, we have a totally different strategy. So for perimeter, it's outside only and adding it all up. For area, it's dividing it into two rectangles and finding the area of each. Okay? Just like we did in grade 7 and 8. So let's call this one area 1 and this one area 2. Okay? So we've got two different rectangles that we want to find the area. We'll find them both separately, and then at the end we're going to add them together, just like we did with numbers, grade 7 or 8. Okay? And this one is kind of the same size as an exponent, but it's down, not up in the air. Okay? So that means area of rectangle 1. So if I just look at the area of rectangle 1, I can still write down, I'm going to do length times width. And I want to choose length to be my term by itself, and width to be the 2x plus 3. So I know both of them. Great. I'm finding the area of the first rectangle that fills that shape. And I know to do that multiplying, I use the distributive property. Okay? So I multiply together. So area 1, the area of rectangle 1, is 6x squared plus 9x. Any questions about how to get the area of rectangle 1? All right, I want you guys now to try to get the area of rectangle 2. This one, okay? And then we'll wait and add them up together. But right now, I want you to try to get the area of rectangle 2. Oh, I see a lot of people got length times width written down. Very good. Okay, lots of people who are having success with area 2 here. They've got length times width. They chose the 2x to be their length. And the 4x plus 7 to be their width. And they have the arrows drawn up. Perfect. Okay. So if you do multiply that, did anyone do it yet? Yep. What did you get, please?
8x squared.
Yep.
Plus
Yeah. Positive plus 14x. Perfect. Okay. So now we found these two. Does everyone see that if it was with numbers, we'd have to add them together to get the combined area? So there's actually a cool way to add these together that I haven't shown you yet, and you might like for area questions like this. So if I've got 6x squared plus 9x, and then I line up my like terms, here's my 8x squared plus 14x, and I do a vertical add, then my like terms are together. Okay? So it's kind of like adding was in grade 7 or 8. So I can do this vertical add here. And I have to call it something. I don't want to call it area 3. I want to call it my total area. So often you use A with a little t there instead of a 1 or a 2. Okay, so the total area is going to be 6x squared plus 8x squared, which is 14x squared. And then positive 9x plus 14x. 23? Positive, so positive 23x. So there's our total area. So when you're finding total area, that vertical addition can be helpful for you, okay? It lines your like terms up for you. All right, that was a big question. Got one more to go. Oops, I went the wrong way. Complete the chart for the compound shape. Show how you found any missing sides. So let's look at this compound shape. Here's one missing side. What's going on? Oh. So see if you can figure out what that side is. And then see if you can figure out what this side is. These are our two missing ones. So work with your partner and see if you can figure out what the missing sides are. And then see if you can figure out what logic you're using to figure out what you are.
This is the total area. So you have all the new options. This is the area. This is the total. We're taking that area. So you know the total is 5 and 8. This would be that last stuff, right? Sort of just put that. When you get rid of this, so we don't need it.
Hey, Mr. Jago, we're on the last example.
Okay.
I really tried hard.
You were this
Okay, can I interject for a second? I've heard lots of really great explanations, but one that I really liked was someone said, don't worry about the x's right now. If this whole big side was 8 and this little piece was 3, this side would be 8 minus 3, which is 5. Okay? But we do have x's, so 8x minus 3x is 5x. Does that make sense to you? This whole bottom is 8x, and if they were just numbers, I'd do 8 minus 3 to get that side. Okay? But it's really 8x minus 3x because we're in algebra now. Okay? So that makes this side 5x. How many people have got 5x another way or some way? Okay? And if you hadn't, does that make sense now? 8x. And then I'm subtracting off this bit here, which makes the whole 8x. That's the 3x. And so that's got to be 5x. Okay? Now this side's a bit trickier. So if I just do the x's first, use a different color. This whole big side is 5x. This much has 2x. I'm just doing the x's first. So how many x's do I need on this side? 5 is the total. 2 on this side. 5 minus 2 is 3, but they're x's. So I need 3 x's on that missing side. Okay? And then I've got 8 ones on the missing side, and 3 ones on the one I know. Sorry, 8 on the total side, 3 on the other one I know. 8 minus 3 is 5. So I need 5 ones to balance out. Okay? Now my count around people will like this because they can look at the 3x here and the 2x here and see if that adds up to 5x. Okay? And they can look at the positive 5 here and the positive 3 here and see if that adds up to 8. So these two vertical sides should add up to the big entire vertical side. okay? And these two horizontal sides should add up to the big long horizontal side. Okay, so that's always a good way to check. So now that you have all your sides, you would be able to figure out your perimeter by adding them up. Okay? So you go ahead and do that now, and then you'll find the area. So everyone add up all your sides, check them out as you go, or count around if you want to count around. So don't miss a side. You're counting around, circle as you go, so you know you mix it up. Yeah, yeah. Yeah, do them in the boxes.
And now we take it and all of the measurements. If you've added all the sides and you're not a counter-rounder, you should have 9 turns after your perimeter equal sign. Okay? So if you remembered every single side, you should have 9 turns. Okay, so check and see if you've got 9 turns. I started with 2x plus 3, and I went this way around. Okay, so check off, check, 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 and check. And that gave me 9 terms. Then, the hard thing about perimeter is you have to figure out the missing sides. The easy thing is once you've got them, then it's just a like terms question. Remember to check up when you got 9 terms, you want to check them off as you write them down in your regroup stuff. So you don't lose track of any of them. Because it's really easy to do when the questions are really getting long like that. Okay? And then again, if you knew there was 9 terms in the first line, there should be 9 terms again. So that's another good way to check. Okay, if you've lined up your 9 terms, now you're putting them in order, there should still be 9. Now you're finally ready to add them up. So 2x's and 8 is 10, 15, 18, 21, 26x. Plus 16, awesome. You got it right? Excellent, way to go. Okay, so area is a totally different setup. Now we're dividing it into 2 rectangles, find the area of the first one and the area of the other one. Okay, so area is totally different than perimeter. So I'm going to erase
Go back to what the original question said and look at it from an area point of view. So you have to decide. The other one kind of decided for you. You've got to decide how you want to divide up the two rectangles. This way or this way. And often there's an easier way. Okay? So since I know this side and this side, maybe I want to divide them that way, but then I'm going to check, do I know this side and that side? Yes. So that's a good way to divide them up. Okay? Once you've divided them up, you're going to find area 1 and area 2 using length times width. And then let's try out that vertical way of adding the two areas together. What way is it? Oh, I like how you did your arrows backwards. Nice. Good catch.
A1 and A2.
Oops. Okay, here's my second rectangle. If you followed the way I did it, I know the length is 3x, but what's my width? I erased it. Does anyone have it still written down, or do they want to tell me how they got it?
It's 3x plus
3x plus 5. Okay, excellent. So 5x minus 2x gives you the 3x. 8 minus 3 gives you the 5. So that's my width. Awesome.
Oh, yes. Clear. Happy birthday.
Yeah, having that as your turn. Yeah.
And which one?
Okay, tutors, make sure your partner gets to the total area there. I'm gonna hand them out the practice. And then you have practice 9, or you can go back and work on practice 8, your choice. We'll continue both of them after the break. And grade 9, you use your time to ask your tutors the stuff that you are a bit worried about. Stop recording.